Well, I might actually learn something new talking to Jacob about this. A process which in meteorology we know takes place, but I never knew it was called this.
If even Chief Meteorologist Kevin Lawrence is learning something, imagine how much smarter I'm going to be.
There's a bunch of words floating around in my head, and this one was from my cloud physics class that I took in college, and it's how
I didn't take that class.
Basically how snowflakes form, ice crystals up in clouds. It's a super cool process, and literally super cooled water. You can sometimes get a bottle of water, purified water, if you put it in the freezer for just the right amount of time to freeze, it's really hard to get the right parameters.
Oh, it's cool.
But this is below 32 degrees right now because it's been in the freezer for a couple hours, and it can sometimes freeze instantly. You can also do it if you pour it over like a bed of ice cubes. So that water that's below freezing, below 32 degrees, turning into ice. And we'll talk about that. It's called supercooled water droplets. That's in these clouds here. And that is part of this Bergeron process. It's a process of ice crystal growth that occurs in clouds containing a mixture of these supercooled water droplets and ice. You can see how these water droplets add to these ice crystals, and we can get these snowflakes to form. So that's the general overview of the process. The cloud is comprised of billions of tiny water droplets, and within this cloud we need those droplets to grow bigger to form precipitation. They need to aggregate essentially onto these snow crystals in order to form large enough snowflakes to fall to the ground. So the supercooled water droplets, it's water that's still a liquid at temperatures below 32 degrees Fahrenheit, and they're microscopic in these clouds. At -4 degrees Fahrenheit, the ratio of the ice to liquid in the clouds can be less than 50%. So even when we're well below freezing, we can still have those liquid water droplets. And in experiments by scientists, cloud temperatures can reach as low as -40 degrees Fahrenheit before all the water droplets are found as ice crystals. So it's an interesting process here involving these supercooled water droplets. And balance evaporation and condensation, these phase changes here, in order to deposit themselves onto this ice crystal for that to grow large enough into a snowflake to then fall to the ground. And this all takes place with those water droplets evaporating and shrinking as the ice crystal grows. So phase changes, again, an important component here when we're going from gas to solid to liquid. The water droplets, water vapor, then the water droplets, liquid, and then the solid, those ice crystals. And we talked about evaporation, condensation. Well, an important one here is deposition. You might not have heard of that for a while, maybe back to your high school science class. That goes from a gas to a solid, and it skips the liquid phase. And this Bergeron process is ice growth by deposition. So going from that gas, the water vapor, right to the solid of the ice crystal here. And you can see kind of the magnified view there. So the ice crystals keep growing as the water droplets gradually shrink around them by evaporation. So the ice crystal eventually gets big enough where it falls as that snowflake. So here's kind of that overview again. We have the water molecules, the cloud droplets evaporating, but they're also through the process of deposition going on to those ice crystals. And the ice crystals are feeding off of those water molecules, and we get the ice crystal, the snowflake, to get larger and larger. So this whole process within the cloud is called glaciation. It's the transition in the cloud of those supercooled ice droplets to ice, and it generally takes place pretty rapidly here. You can see sometimes it just takes a little nick or some sort of nuclei, some like droplet or a speck of dust, or just the right temperature for that to occur, for that to turn into the ice with that ice crystal, and then for it to grow. So the crystals, as they're falling through the cloud, they're growing as the water droplets are shrinking, especially in this specific layer of the clouds with the right temperature and humidity values where we can have rapid snowfall, rapid snow growth, or you get some specific types of snowflakes to form there. So as the ice crystals become larger and heavier, they fall into the lower levels of the clouds. That increases the number of ice crystal surfaces available, so more of these water droplets can attach to those ice crystals. You get more of the deposition to occur as well, and the amount of water vapor decreases. So you can see how all of these supercooled water droplets can kind of condense or form onto this ice crystal here, and the ice crystal is growing by that Bergeron process. So ultimately, it's the temperature and to a lesser extent the humidity of the air in that cloud level that determines the basic shape of the ice crystal and how fast that snowflake grows. The underlying structure of the crystal is hexagonal. As the water molecules cool, they take on their lowest energy form between attractive and repulsive forces with other molecules around it. So that's why we usually get the six-sided snowflakes. You can also get these needles, which don't stack up as efficiently as dendrites, which are the most intricate. That's when you get your heaviest snowfall. The snow can accumulate pretty rapidly. When you have upward motion in the clouds with these forming, and that just supplies more supercooled water droplets to then aggregate or through the process of deposition, go onto those ice crystals and form the bigger snowflakes. So the types of snowflakes here determined by the cloud temperature. You have the plates, the needles, the columns, and those dendrites all forming at different cloud temperatures. And all through that process, the Bergeron process, when you have those supercooled water droplets forming into the ice crystals. So clouds routinely extend upwards into these sub-freezing temperatures. That's why we can have this process form. And most precipitation types start off as snow before, if it's rain, that snowflake would melt above freezing temperatures all the way down to the ground, and it would contact the ground as rain, as liquid. Freezing rain is actually supercooled. That's why when it makes contact with any surface, it freezes right on contact. It's still in the liquid form, even though it can be below freezing for a bit before it makes contact with the surface. So determining the ratio of those supercooled water droplets and the ice crystals is really important for us when forecasting precipitation types and snowfall amounts. The other process of precipitation forming in clouds is collision-coalescence. This is more for warmer clouds that don't extend all the way up into the freezing levels of the atmosphere, mostly during the summertime. And this is where you have a bunch of really small, those cloud droplets, the water droplets. They need to increase in size almost 1,000,000 times to get heavy enough to fall to the ground. So the larger droplets tend to fall faster. They collide and stick together. That's where the coalesce comes from, with those smaller droplets in their paths. And these water droplets eventually grow large enough to fall from the cloud as raindrops. They can also reach a critical size where they break apart because they're too wide, but they are usually kind of shaped as these like flat discs before they would break apart. But you can get these to form, again, in warmer clouds where you don't have the cloud reaching up into some freezing temperatures. But a couple of interesting ways that we get precipitation, whether it be just in the form of rain or with snowflakes. And we're not seeing a whole lot of snowflakes around here right now, but in the wintertime, when you have these snowflakes form, they can come down as those pristine dendrites. And it's all thanks to the Bergeron process.
And it's fascinating.
It is super cool.
It's super cool,
Super
and it's
cool.
one of the fundamental concepts of meteorology.
Yeah.
I just did not know that was called the Bergeron process.
It's named after a scientist that kind of developed it,
Yeah, not Doug Bergeron,
No.
not Doug Bergam, but the Bergeron process.
Yeah.
All right, thanks,
Cool.
Jacob.
Thanks, Jacob.